Okay, so something which may happen during the project, that you may have to compress the project in terms of the timeline, in terms of the duration. Okay, so this is called as project compression. So our topic today is going to be about project compression. And so we are talking about a schedule compression. Okay, so we are not compressing the scope of work, we are not compressing anything else. We are basically focusing on compressing the project in terms of time. So there can be other compressions as well, scope compression and budget compression. But what we are talking about now is schedule compression. Okay, so project compression can be of many types, but we are only discussing compression of the project, reducing the project in terms of schedule or time. Okay, so we have talked about earlier that we prepare a Gantt chart, and before that we make a WBS, and then we go for CPM and PERT. And in PERT we need so much analysis, and we need three durations, and we have to do this and that. So a lot of work has already been discussed about how to find out the actual plan, the original plan of the project, okay, the duration and so on. So after doing all this, why would we want to disturb it? Okay, so you already spent so much time and effort in preparing your initial plan. Why do you want to disturb it? So these are some of the reasons where a schedule compression may be required. Okay, so maybe the client is in a hurry. So you are making a mall, and the clients want it to be completed before Eid, before Ramadan, or before National Day or whatever. Okay, so he wants early occupancy. Okay, or maybe you are doing a hotel or something, and the client wants you to do it as fast as possible so he can he can start renting out. Or it could be a production plant. Okay, or it could be a power plant, that the earlier you complete it, the better it is for the client, so that he can start producing the things which the plant is doing. Okay, you may be forced to do it because the client is offering you some incentives. Okay, or if you do it late, you may have some things which may not remain useful. Okay, so they call them liquidated damages. Okay, so the client says that if you do it after this time, then I will not need this work. Okay, if you do it, if you can't finish it in 6 months, then I will not ask you to do the landscaping, for example. Okay, so liquidated damage is something which, if you don't finish in time, then after that time that thing is useless. Okay, so for example, in current scenario, you want to go from Bahrain to some places, and you booked a taxi, and okay, so the taxi is only valid for this time, and you cannot take a direct flight from Bahrain. Okay, but after that time passes, inshallah soon, uh, that taxi service is no longer useful. Okay, so that is the liquidated damages. So after some time the thing becomes useless. Okay, so those are the liquidated damages. So the point is that it could be that if you finish early, you may take more advantage of something. Okay, it could be an incentive from the client, or something which you may lose from your own organization. Unforeseen delays, so you are going according to plan, but you faced a delay because of safety issues, because of uh, a change in the design, because of a material shortage, because of you were expecting something you were that was coming from some other country, and it did not reach in time. So you were actually trying to go according to plan. So the compression is not initiated by you, but now delay has happened. So in order to keep yourself with the deadline, with the plan, you have to do compression. So without compression, you may not. And there are many cases like this, especially in the construction industry. There are many cases in which you have to do compression to be with the plan. to execute as per the plan, because some delay has already happened. So delay is a very common feature in the construction projects. So even to maintain your plan, you have to do some schedule compression. Uh, and the last thing is like is related to organizational management, which is resource availability. Okay, so if I don't finish this activity in 1 week, so I'm using an excavator here or a mixer here, okay, or I'm using 5 extra labor here, and then after this week I need the same machinery or the same people on some other project. So if you if you can finish this before time, then your resource will be available before the deadline, and you can use it somewhere else. Okay, so in the last case, it is not because of this project, it could be because of some other project. So I want the resource in some other project. To make it available for that project, I have to do compression for this one. Okay, so these are the decisions which are taken at the organizational level. Okay, you don't only look at what is happening within the project, you have to look beyond the project as well. And sometimes you make changes because of what you may achieve in some other project. Okay, so compression means, schedule compression means you are trying to shorten the duration of the project with least impact on cost, scope, and quality. Okay, so we are just trying to change the time. Ideally, okay, the ideal scenario is what? You compress the time without any change in anything else. This is ideal. Okay, but obviously this is not possible. If it was possible, then the client will ask you, why were you asking me for more duration to begin with? Okay, if you can do the same project in 2 months instead of 3 months without any changes in cost, quality, and scope, then why were you asking for 3 months initially? Okay, so it's very difficult to compress the project without any changes in the other parameters. In the initial slides, in the initial couple of topics, we talked about these 3 pillars of project management, which was the time, cost, and scope. Okay, and the quality, I told you, is at the intersection of these 3. So in many cases, this is not possible, that you achieve compression in project without achieving or without changing the other parameters. Okay, now what we are going to discuss is okay, we are only going to discuss the impact of one of them on the project compression. Okay, in the class. Okay, so cost, scope, and quality, which one can be discussed within the class? Like obviously in the class I don't have a client here, I don't have the specifications, the drawings. So out of cost, quality, and scope, which of the things can be discussed within the class? Tell me, or take a guess, no problem. Scope, quality. There's only one thing left, huh? Nobody's going for that. One more for scope. Time, yes, time, we are discussing time. So, but I'm saying time in relation to what? Okay, so you are saying we will, or some of you are saying that we will discuss what is the impact of time on scope and what is the impact of time on quality. Now, for both these things, we need the consent of the client. For scope means what work you have to do. Okay, so obviously then this cannot happen if I don't have the client. Like if I tell you, okay, you have to compress the project, and it's a 2-story villa, and you have to compress it, and so you would say, okay, I will just make 1 story. Okay, but is this acceptable for the client? Okay, so this is the main thing. What? No. Anyways, my point is that the client basically decides what is the scope and what is the quality. So in terms of discussing in the class, okay, we can focus on the cost. Okay, so if you take the decision in your hand, then there is nothing to be discussed. Obviously, we all know that two-story villa will take more time and one-story villa will take less time. Okay, so there's nothing to be discussed. If you change the scope, the work is changed. You need less time. There's no science in that. There are no techniques required here. Okay. Or on the other hand, if you say I will compromise on the quality, again that is something which if you decide I will do it and the client approves, there's nothing to be discussed. Okay, so for that we don't need a discussion. Okay, or we don't need some analysis to prove that. Okay, so what we are going to focus on this in this class is the impact of compression on the cost. Okay, so we will focus on the cost. Okay, so for this compression we have two techniques, fast tracking and schedule crashing. So for schedule compression we have two available techniques. One is called as fast tracking, the other one is called as schedule crashing. Fast tracking means that you do the activities which were in sequence in parallel to make the project finish earlier. So there were some activities which were supposed to happen one after the other. So what you do is, in order to make the project faster, you begin some of them in parallel. So the first one has not finished yet and you start with the next one. So they don't have to be completely parallel, but what we mean is you don't wait till the end. Okay, I will show you some examples, but parallel doesn't mean that the complete activity has to be simultaneous. It doesn't mean that. Okay, but what it means is I will not wait till the end of the first activity to start the next one. Okay, I will start it before the end of the first activity. Okay, so this is called as concurrency. Okay, concurrency means that you are doing them in parallel. Okay, or some part of these activities is happening parallel, and the other the opposite of that, the normal one, is sequencing. Okay, so we have concurrency and we have sequencing. So let us take this example. So what you see in this flow chart is the normal procedure of any construction project, that you will do the design, you will take the permit from the government, the Ministry of Housing or whatever, or municipality, I don't know, and once you get the approval from them, you will go for hiring the contractor, and then the contractor will do the construction. Okay, so this is let's say this will require 16 weeks to finish if you do them one after the other. In order to make them fast, obviously there are some activities which I cannot make parallel. For example, permission and design. I want the activities to happen parallel, but the government will not give me the approval until the design is complete. Okay, so the permission and the design cannot be parallel because the government doesn't work this way. Okay, so you go for the next stage. So design and permission have to be one after the other. The next one is procurement. Okay, procurement means you are buying material, buying equipment, buying other resources. Okay, or you are negotiating with the contractor. So once the design is finalized, even in Bahrain, I'm not aware of any law which says that you need to have an approval before you go for the hiring of the contractor. Okay, so it's still you may say, okay, I have submitted the file. Usually if there's something wrong, they return it back within 2 days. So you may wait for 2-3 days. If the file has not returned, now you know that it is going to be approved, but it will take time. Okay, so I will not wait till the end when the approval comes. I know within 2-3 days the file did not return, that means everything is fine, I can move ahead. So now you can go to contractors with your design, that this is the design and this is what I want to be constructed. Okay, and the procurement, this is the procurement stage. Okay, so if you are doing it yourself, you are the big organization who does design and construction and everything yourself, then your procurement will be hiring people, hiring or buying material and so on and so forth. But any type of procurement, okay, it could be procuring the contractor or procuring the resources for the construction work. Okay, so you can start it when the permission process has already begun. So you wait for a few days and you are now sure that it has already taken initial approval. I am just waiting for the final order so I can start, because I know there is very little chance that my design will change now. So you start the procurement, and once the approval comes, you can start the construction as well. But because you already started the procurement earlier, so the construction will not be after the procurement. You already have something on the basis of which you can start the construction work, the site clearance and excavation and these things. Okay, initial work can be started. So you can see here permission, procurement and constructions are overlapping, but they are not completely overlapping. So they are not completely parallel. But procurement does not start after the end of permission, and construction does not start after the end of procurement. You can see it's like half and half. Okay, so this parallel thing is what is saving your time. So maybe you are saving 2 weeks of parallel work here, 3 weeks of parallel work here, and so on and so forth. So this is how you compress the project to a lower duration. Okay, other examples of fast tracking, for example in construction work, you start doing the foundation work before architectural drawings are ready. Architectural drawings, they will give you elevations, right? Elevations, doors, windows and these things, but the structural work is already complete. So you don't wait till the details. Okay, I need architectural drawings at the time of finishing, once I have done the substructure and superstructure. So by that time it will be finished, but I already have the details for the structural work. I can start with the foundation work, even maybe the whole substructure. Procurement is a phase of the construction work. So you may start ordering items which will take longer time. So they are called as long lead items. Items which are coming from other countries, items which will take longer time to arrive after the order. So these are not the items that you can go in the market and just buy them. So these are the items which will order them and you have to wait. So in order to reduce this or in order to overlap this waiting period with the other work, you may order these items beforehand. Okay, so even during the preliminary design phase, if you have an idea. Okay, so the final design is not ready, but you know that I need approximately this much steel. Okay, or some other item. Okay, and the good thing is construction items, most of them are not they do not they do not expire, right? So steel, for example, you ordered it, or cement. Okay, cement is sensitive, but steel or aggregate or some admixture which is or paint or something like this, they do not expire very quickly. So maybe you ordered it for one project a little bit more than what you require because you didn't know the exact quantity. So once the project finish, you can use the remaining item in other projects. Okay, in some cases you can even sell it. Okay, as I have like this much paint available, anybody can take it. Okay, they can use it and so on and so forth. So this is good about construction work. In software projects, you may begin the development before the user interface designs are approved. Okay, so like you know the interface is what you see in front of you, and the development is the coding behind. So you may start the coding before the interface is finally approved, because you know the main things are already decided. Okay, another example of a fast tracking, you have a office fit out project. Office fit out means internal work of the office. So we are not constructing the office building, it's already there. We are doing whatever is inside the building. This is called as fit out. Okay, so putting shelves and interior decoration and these things. Okay, so initially, without fast tracking, the project was supposed to complete in 8 weeks. In 8 weeks, 3 for design, 4 for procurement, and 5 for the work, the construction work. Okay, and but the client is saying now, I need the office to be occupied after 6 weeks. Okay, my staff is waiting, or I have this project to be completed. I have these many orders. So if you don't finish my office in 6 weeks, I will lose the value of my other clients. So what is the solution? You start with the overlapping fast tracking. Okay, so there are three main phases. You overlap the other two phases with the first one. Okay, so procurement can start when 80% of the design is ready, not 100%. 80% we start the procurement, and because we already have an idea about the construction quantities. And so during the procurement phase, the design will be finished and you can finish the procurement as well. And the construction will happen in parallel to the procurement. So once you have started the procurement, uh, the the construction work is going on with that as well. So at the same time, so you hired some labor, some equipment, and they started doing the job at the same time. So construction and procurement are starting together, but after 80% of the design is finalized. Okay, so with this you are compressing the project. So it was supposed to be week 1 to 3 design, then after design you have week 4 was for procurement, 1 week, and week 5 uh, 5 weeks, 3 plus, I don't know what is happening. So it's supposed to be 8 weeks, 3 plus 1 plus, I don't know. Anyways, so with the fast tracking, with the parallel work starting, you can finish it in 6 weeks. Okay, I have to look at these numbers. Should be fifth week. Okay, fifth week, and then 3 weeks more. Should be like this to complete in 8 weeks. Okay. Anyways, another method of so before I move to the next method, so we have said that yes, something like this. Yeah, overlapping. Overlapping is part of the fast tracking. Okay, so and what you are saying, Faris, is also true. So before I move on to the next technique for schedule compression, in fast tracking, when you are deciding about the activities which can happen together, what do you need to know, or what you will consider? How do you decide which activities can be compressed and which activities can sorry, not compressed, which activities can happen together or not? Yes, how do you decide about the fast tracking options, that I should compress or I should make these activities parallel or not? Yes, you can look at the dependency charts. Yes, so you already have the dependencies. And how do you decide the dependencies? That's another question. We did it in the last lecture, but how do we decide? It depends on the type of activity. Okay. Yes, it does depend upon the type of activity. So basically it's based upon the engineering judgment. Okay, dependencies, they are based upon engineering judgment, and based upon dependency you decide whether the activities can be parallel or not. Okay. Uh, so in the fast tracking, you need some engineering judgment to decide which activities can be made concurrent, okay, and they can, and to what level they can be made parallel. Okay, so like in this case they are saying 80% of design should be ready. Okay, so who said 80? Why not 50% of the design? I will have more concurrency in my schedule. Okay, if I just wait for 50% of design instead of 80%. Okay, so I will have better compression. Okay, but in the end it's your judgment. Do you need can you work with only 50% of the design with on your procurement or not, and so on and so forth. Okay, just one thing, I just noticed this note over here. So the procurement and construction are already happening parallel, because they are saying the, so you can see the dependency here. After design, procurement and construction both can start parallel, so they are like this. Okay, so design this one and then design this one, so they are parallel. Okay, and obviously the final so this is how they have put it in the example. Okay, but obviously you know that until the construction is finished we cannot say the project has finished. Okay, so even in this original plan, even in the original plan, the procurement and construction are parallel. Okay, and this is what we saw in the previous examples, the ones which we did before Eid, that there are multiple paths which happen parallel. Okay, so even without fast tracking some paths can be made parallel. Okay, so the fast tracking will provide you more compression even from the initial plan. So initial plan could have parallel activities. Okay, initial plan could have parallel activities. So this is how we got 8 weeks in the end. So 3 plus 5, because 3 for design, without design both of these cannot start. Okay, and plus 5 because until the construction finishes the project will not finish. So 3 plus 5 like this, and you can see the same thing over here. Okay, so yes, so now we are going to the other technique of schedule compression. So the first one was fast tracking, the second one is schedule crashing. Okay, schedule crashing means you try to reduce the duration of the project by reducing the duration of activities. Okay, by adding more resources. Okay, so if 5 people can do a job in 1 week, so in schedule crashing may hire 7-8 people to do the same job, okay, in 3 days instead of 1 week. Okay, so this is called as schedule crashing. So obviously when you will hire more resources you have to pay extra to them. So you need to pay extra for the extra resources. So this is where you will this is where the term comes as money for time. As schedule crashing, you are negotiating between money and time. Okay, so I want to decrease the time, so it may increase my cost. It may, okay, we will see. So in some cases the increase in cost can be very minimal, and some cases it can be very significant. So this is why we need to do some analysis to decide how to do the crashing. Okay, but basically it's a trade-off, or it's a compromise between time and money. You want to decrease the time, you may have to increase the cost. Okay, so a project, even this project has 3 activities. This one has 4 activities. So a project has multiple activities. So you need to decide which activities to be crashed. Okay, you cannot crash all the activities together. Okay, so you need to decide which activities to be crashed. So how do you decide about the activities? First of all, the activities which you have said, one activity, it could be more than one as well, but any activity which you have selected for crashing must be on the critical path. And this is again something which we have discussed earlier. Okay, so what was the condition of critical path? Anybody remembers? The path which gives you what? I will just summarize it in one sentence. The path which gives you what? Least time between 2 points? No, it's not the least time. Longest time, maximum time, yes. Okay, but not between 2 events, between the start and end of the project. The path which gives you the longest time between the start and end of the project. Okay, and we also discussed that the float on this path should be 0 and so on and so forth. Okay, so and we discuss about drag as well, then drag will come into play here. Okay, so I hope you remember those terms and their meanings. Okay, so because the duration of the project comes from critical path. Okay, so if you are compressing an activity which is not on critical path, then it will have no effect on the project duration. Okay, activity which is not on the critical path, so that activity was not affecting the duration from the start. So whatever you do with this activity is useless. So you should compress a critical path, or sorry, an activity which is on critical path, because that activity contributed to the actual duration of the project. One thing. When we were discussing this, I believe it was Hussein who mentioned this, that can we have more than one critical path? So yes, we can have more than one critical path. And I said at that time as well, if you have more than one critical path, it is possible, but it is very difficult to handle, because anything which happens on the activities on any of the critical path will disturb your project. So now when you are doing the crashing, the schedule crashing yourself, you have to do it on both the critical paths to have the effect. So for example, you have 2 critical paths, both of them are giving the same duration, let's say 60 days. So if you do the compression on one critical path, so that path goes from 60 to 58. The other path is still 60 days. Okay, so if you only compressed one of the path, in order to finish the other path, you still need 60 days. So the project will still finish in 60 days. Okay, nobody will say that I'll finish the project with this one path only. It's not possible. So if you have multiple critical paths, then you have to do same amount of compression in both of them in order to achieve the required outcome in the final duration. Okay, because if you have multiple critical paths, you only do compression in one of them. After compression, that will become the non-critical path, because that path does not have the longest duration now. Okay, so it will become the non-critical path. Okay, so if I do 2 days of compression on one critical path, if I have another one, I need to do the same amount of compression on that one as well. So in total, I will have 2 days of compression. Okay, so this is how it goes. If you did 2 days compression on one path, 1 day on the other, in the end, you will compress the entire project by 1 day only. Okay, so in the end you have to look at the longest path. How much did I reduce on the longest path? Okay, so if there are two parallel, both of them are longest, you have to compress them by the same amount to have that much effect in the duration. Okay, then obviously we will select, so we have selected the path. That path may have 4, 5, 6 activities. Now out of these 6 activities, which one should I crash? Which one should I select to reduce the duration? Because we are doing for time for money, right? So if I reduce, I will have extra cost. So I will select the activity which has the least extra cost because of compression. Okay, so what does it mean? If I compress activity A, I will need 2 extra labor. If I compress activity B, I will need an extra mixer. Okay, so the mixer will cost me, let's say 50 BD for 1 day. For one extra day, I will need 50 BD. I need to pay 50 BD. So if I do activity B, I will pay 50 BD per day for the mixer. If I do activity A, I will only need to hire 2 laborers for an extra day, and 2 laborers only cost me 30 BD, let's say. You know, people are cheap, right? Machines are expensive, right? So so you see now activity A is cheaper to compress. The extra cost of compressing activity A is cheaper, it's 30 per day, but for activity B it is higher, 50 per day. So my preference will be, if both of them are on the critical path, my preference will be activity A, which requires less per day extra cost. Okay, and yes, you need to select an activity which can be reduced, okay, which can be compressed. So I'm just doing, for example, let's say I have to finish the installation of the ACs, okay, and the minimum time for installation of all the ACs is 2 days, and the person who is doing it has already written 2 days in the schedule. So no matter what I do, I need those 2 days. It cannot be done in less than that. So compression is not possible. So if you have choices, some of the choices may not be possible. So possibility must be seen as well. And the last one is related to the second one, but now they are saying you don't look at the total extra cost, you have to look at per unit extra cost, okay, per day extra cost. Okay, so what is, you get the idea what I, from the example I gave you. So the example I gave you, I told you 50 per day and 30 per day. Okay, so I'm looking at per day extra cost or per unit time extra cost. Okay, so there are 3 main points here. Okay, 4 are mentioned, but 2 of them are interrelated. So there are 3 main points here. The first thing is, so 3 main points for selecting activity for crashing. The first main point is it should be on the critical path. The second thing is it should be the cheapest one to crash. The third thing is it is possible to crash it by adding extra resources. And going back to the question which I raised at the start of the lecture, we are not talking about scope and quality. Okay, so because if you include that, then you can compress any activity which you want if it is on the critical path. Okay, I wanted 10 ACs. Okay, I'll reduce it to 8 ACs. Now it is possible to compress this activity as well. Okay, and even without extra resources. Okay, so we are just talking about reducing the time and looking at the effect on cost. So scope and quality is not included here. Okay, so if you want to find out the cost per unit time, the extra cost this the crashing of this activity will have for you, this can be calculated using this equation. Okay, so crash cost minus normal cost divided by normal time minus crash time. Okay, so you can say that normal cost is what you were asking for, normal with normal number of resources and so on and so forth. Crash cost is the cost you will ask for if you maximize the resources. When you maximize the resources, your time is minimized. Okay, so crash time is your minimal time. So crash cost is with maximum resources, maximum possible, and crash time is with minimum possible time. Okay, so this will give you per time cost. It could be hours. Okay, some activities are measured in hours. Okay, and some activities are measured in days, and some of them are measured in weeks. Okay, for example, design or construction work, the whole construction work can be measured in weeks. Okay, but there is, for example, uh, plaster, which may be measured in days. Okay, for smaller projects in hours. So the time can vary, the unit of time can vary. Okay, so to do schedule crashing, you have to follow these steps. The first step is define the critical path. So you have to do the analysis which we have done before the Eid break, that you have to find out which one is a critical path. Then you identify the activities that can be crashed. So then you look for the other two possibilities. Is it possible to crash, and which one is the cheapest one to crash? Okay, and then you identify the crash limits. Okay, the maximum resources you can have, which will give you the minimum time it can be done. Okay, so yes, I can crash excavation from 3 days to 2 days, but can I do it less than 2 days? Not possible. Okay, it will require 2 days in any case. So this is my crash limit. So crash limit is the maximum amount of time by which you can reduce the duration of the activity. Crash limit, the maximum time by which you can reduce the duration of the activity. That is your crash limit. Okay, then you calculate the total cost, extra cost because of crashing, and what will be the benefits. Okay, so the benefits are in terms of time. The benefits are in terms of time. So how much time can I reduce, and then that will have how much effect on the cost. And then once you have done that, you need to get the approval. This is something which is related to project management, the approval process and communicating and so on and so forth. Yeah, for crash limit, again, you have to look at the market data. You have to ask your supervisor. So this is something which comes from, again, experience and judgment. And yes, you have already done some sort of thing like this in quantity estimation. You have already calculated quantities, but you did not consider adding extra resources and so on and so forth. Once you get into the business of construction, they will tell you, you will know how many laborers can I hire and so on and so forth. For example, I'll give you one example. I need one excavator to work for 3 days on my site to finish the construction. Okay, if I hire 3 excavators at a time, okay, these 3 will finish the job in 1 day, right? So I can, so instead of 3 days for one excavator, I can do 3 excavators for 1 day. Okay, this is a very simple example, but what I was saying is where your experience and judgment comes into play. Can I keep 3 excavators on my site in a day at the same time? First of all, does my company have 3 excavators? Maybe they only have 2 excavators. So doing it more than 2 is not possible. Second thing is, maybe if I bring all the 3 excavators on the site is a small site. You know, excavator takes space and it needs a space to move around as well. So even if you hire 3 excavators, all 3 of them cannot work at the same time on the site. Okay, so this is where the experience comes into play. But you know the simple formula, the simple concept is, I need 40 hours of work. So if one man is doing 8 hours per day, then he will need 5 days. If I hire 2 people, then they will need 2.5 days to finish the same work, because they will do 8 hours parallel. Okay, so this is the simple concept. Okay, the simple concept of crash limit is, okay, how many people I can add and which will work parallel. But at the same time, you have considerations like the size of the project and the availability of resources in your company, and also in some cases the type of activity itself requires some time. So if I say concreting, after concreting we need to do curing. But until the concrete takes strength, I cannot move forward. Okay, so if somebody says, okay, I will have 7 days, so I cannot compress these 7 days now. Okay, so the crash limit is, okay, I can finish the concreting instead of 2 days in 1 day, but still after that I need 7 days. Okay, so if the total was 9 days initially, I'll compress it by 1 day, so it becomes 8 days. Can I compress the remaining 7 days? No, because that is for the strength gain of the concrete. Okay, so this is where you need to look at the type of activity and all these things. Okay, this is an example which I showed you in the last lecture as well. Okay, and we already did the calculation for that. Okay, so just to remind you, this is my critical path, the one which is followed by the red arrows. Okay, the duration on the top. Okay, the blue times are the early times, and sorry, the green times are the early times, and the blue times are the late times. Okay, and the total duration of the project is 65 days. Okay, so on this one now you can see the term drag here. Okay, and I told you earlier, drag is the amount of time you can compress an activity while it remains on the critical path. Okay, so I told you the critical path is the longest one. The critical path is the longest one. So how much I can compress an activity so that it is still the longest one in comparison to the parallel activities. For example, if you look at activity B has a duration of 20. Okay, if I make it 15, you can see the parallel activity here is 15 and here is also 15. Okay, so until activity B is up to 15 days, it will remain on the critical path because other activities have equal or more duration. So if I make activity B as 18, comparison to F and H, it is still the longest activity. Okay, if I make activity B 17, again still the longest activity. If I make activity B 14, okay, 14 days instead of 20. So that means what? After when I move forward from A, either activity F will give me the longest duration or activity H will give me the longest duration. B cannot give me longest duration with 14 days of work because other two activities are already longer. So this is the concept of drag, and this gives you the one of the crash limits. Okay, one of the crash limits. So you need to keep the activity on the critical path. Okay, another thing, if I compress activity B to exactly 15 days, so F is 15 days, H is already 15 days, and then I compress activity B to 15 days as well. What will happen? I already mentioned it a couple of times. So if all these three activities have the same duration, what can happen? I'm not saying that it will happen, but what can happen? What is the negative point? If all activities which are in parallel become the same duration, what can happen? What problem we may face later on? Yes, we will have multiple critical paths. Okay, we may have. Still, you need to finish the entire forward pass and backward pass to see if we have. Sometimes you may not have. Sometimes you may have. Okay, so you are asking about crash limits. So one of the ways of finding out the crash limit is that you look at the drag value. Okay, but the drag is just for the sake of the network. Okay, the drag does not show you what is actually happening with the activity. Okay, so activity B, yeah, the drag is saying that you can reduce it to 15 days, but is it really possible to reduce activity B by 15 days? Anyways, so the drag gives you an idea about or one of the estimates of the crash limits. Okay, so this is what I mentioned. Uh, yeah, so if I reduce activity B from 20 to 16, then I'm reducing the whole I'm reducing activity B by 4 days. So the whole project will be reduced by 4 days. So this is the benefit of having an activity reduced on the critical path. So you will have the same effect on the overall project duration. Okay, because this activity was adding to the duration. So if you reduce that activity by 1 day, whole project reduces by 1 day. If you reduce by this activity by 2 days, the whole project will reduce by 2 days, and so on, so on, until this activity is on the critical path. Okay. And I have used so drag is the term which they use for the activities on the critical path, okay, which shows how much the activity can be compressed. For non-critical activities, so F, G, and H, these are non-critical activities. We use something which we call as the float, which is the difference between their early and late time. Okay, so 40, 45, the difference is 5. So the float for this activity, total float for this activity is 5. Okay, or if you are comparing between two activities, for example F and G, so you can see the end time is 25 and the start time is 36. So we have a difference of 10 days. So this will be called as free float or free slack. Okay, so for non-critical activities, we look at the difference between their early and late times. Okay, either between two activities or for the same activity. If you are doing it for the same activity, we call it total float or total slack. If you are doing it for two different activities like F and G, we call it the free float or the free slack. Okay, but the drag is the term for compressing the activities on the critical path, while float is the term for non-critical activities. Okay. I already showed you this thing. Okay, if activity is off the critical path, its drag is 0. For non-critical activities, the drag is 0 because it doesn't matter. Even if you compress, it doesn't matter. Okay. If activity is on the critical path and has nothing in parallel, its drag is equal to its duration. Okay, because there's nothing else happening in parallel, so drag becomes equal to duration, because I told you you can only have the drag in comparison to other activities, because you need to keep the activity on the critical path. So if there's nothing to compare, the drag becomes equal to duration. The thing which you can see with activity A, there's nothing parallel to activity A, so drag becomes equal to duration. Same thing with E, there's nothing parallel to E here, so the drag becomes equal to duration. Okay. Okay, so they are saying if you have parallel activities, then the drag is either equal to the activity duration itself, or the total float, or the parallel activity the least total float. Okay, so if I go here the float is 20 days. Okay, 11 minus 31, 20 days, and here the total float is 15 days. Okay, so according to this rule, what they are saying, according to this rule, it will be either one of these two. So if I look at activity B, the driver activity B is equal to duration or total float of the lowest total float of the parallel activities. So the parallel activities are F and H. The total float of F is 15. The total float of H is 20. and the duration of B is also 20. So I have to take the least of these three numbers. Okay, so you can take duration or the least total float. So for activity B in my chart, duration is 20, total float is 15 and 20. Okay, so out of all these three numbers I will take the least one, which is 15. Okay, so this is like, if you just want to have a look at it quickly. Okay, you just look at the three numbers. Okay, you have done the network analysis, just look at the three numbers: 20, 15, 15. Okay, or 20, 15 and 20. So the least one is 15. Okay, so drag is 15. Okay, activity C has nothing in parallel. Now you see activity C has nothing in parallel. Okay, nothing goes after B to somewhere else. So drag equals to duration. Okay, then activity D is critical path, so I'm doing it for D. I have duration 10, duration is 10, and I have the total float on this side, which is 5. Do I have another activity here? No. So I have two parallel activities, D and G. D is on the critical path, duration of D is 10 days, and G is non-critical, and total float for that is 5. So drag is the least, 10 or 5, 5. Okay, so this is how you find out the least, sorry, the crash limit basically. Okay, so they have given a very good rule here, three rules. Non-critical activity, drag equals 0. Non-critical activities have floats, total float, free float, and so on. Critical activity, nothing parallel, drag equals to duration. Critical activity with parallel activities, drag equals to duration or minimum float, whatever is minimum. Okay, so this is these are three rules which can help you do the calculations quickly. Okay, so let's say we have this. Okay, so it's not, I believe it's not for the same project, but we have this. So we have activity A. After activity A, I have B, and after B, I have C. So very simple linear project. Okay, A. I'm just making it for you for the sake of explanation. Okay, and C. Very simple linear sort of a project. Okay, I have a deadline to complete this project in 22 days. Okay, now I can do fast tracking, right? But for that I don't have the data. Like I don't know what is activity A. Is it design? Is it concreting? What is it? Okay, so for fast tracking you must know that type of activity. Okay, so if I just give you A, B, C, D, E, and I say do fast tracking, make them parallel, and so you cannot do that. Okay, so you need more details for fast tracking about the activity itself. But for crashing, you have the data in front of you. So we have the normal time and the normal cost. For activity A, 7 days will cost me 5,000. Crash time 5 days, crash cost 9,000. So if I try to finish the activity A in 5 days, I will have a total cost of 9,000. Okay, and then for activity B, I can go from 9 to 7 days, so 2 days less, and it will have a cost of 12,000. Then from 8,000 it will increase to 12,000. Okay, and then from activity C can only be crashed by 1 day. Now see, activity C can only be crashed by 1 day. Okay, so you cannot do it 2 days. So this comes when you know what activity you are talking about. But for the calculations, we can do the calculations, the numbers. Okay, so in the normal sequence, 7 plus 9 plus 10 days, so total 26 days. The whole project will finish in 26 days, and it will have the normal cost, the addition of the normal cost. Okay, so there is nothing parallel here. So I'll just add the days and add the cost. In any case, I will add the cost. Cost will be added, obviously. Even if the activities are parallel, I have to add the cost, but the duration will not be the same. So in this case, A, B, C is the critical path. There is no other choice I have. So I have to just add their numbers to get the time. Okay, now since I have only one path, so this is my critical path. So I have to select one of these three activities, A, B, and C. Okay, one of these three. Which one should I select? I will calculate the crash cost per day for each one of them. Okay, I'll calculate the crash cost per day for each one of them. So how do I do that? For example, activity A, crash cost minus normal cost divided by crash time minus normal time. Oh, sorry, normal time minus crash time, to avoid the negative sign. Okay, to avoid having a negative dollar. Nobody wants negative money, right? So money is negative, but nobody wants negative money, right? So for activity A, if I compress it from 9,000 to 5,000, I have to compress it by 2 days. So 9,000 minus 5,000 divided by 7 minus 5. So each day of compression is costing me $2,000 for activity A. Then if I go for activity B, I will increase the cost to 12,000 from 8,000. I'll reduce the days from 9 to 7. So again $2,000 per day. Then if I go for activity C, the cost increases from from 4 to 5, and the days decrease from 10 to 9. So it's $1,000 per day. So out of these activities, on the basis of this, I will crash activity C. Okay, how much can I crash activity C? 1 day only. The crash limit from 10 to 9. If I crash it from 10 to 9, I will increase the cost by $1,000. I'm reducing the duration by 1 day, and I'm increasing the cost by $1,000. Okay, so this one will become 25 now. Okay, and the cost will become 18,000. Okay, but I want to reduce it to 22 days. Okay, so now I have to select the next activity to be crashed. Okay, now if you look at the other two remaining activities, activity C is out of the question now. You already reached its maximum limit, which is, or minimum limit, which is 9 days. So you have to look for other activities. If you look at activity A and B, both of them have the same per day extra cost. Okay, both of them have the same per day extra cost. So you can do any one of them. Okay, so if you reduce activity, you can reduce activity A by 1. Okay, and then reduce activity B by 1, and so on and so forth. Okay, so these are the iterations which are given, but you understand the idea. Activity C, the first step, then activity A by 1 day, you go from 25 to 24 days. Okay, and you add the cost by $2,000, which is the per day cost for A. The critical path in all cases is the same because we don't have any other path. Okay, then here activity B by 1 day, so we are trying to balance. Okay, you can do 2 days for activity A complete, and then 1 for B, is up to you. Okay, but in terms of the cost, they don't have any effect. Okay, activity A or B, they are having the same extra cost per day, and both of them can be reduced by 2 days only. Okay, so I wanted to bring the cost from 26 to 22 days. So in the end, I have to reduce by 4 days. I already did it for activity C by 1 day. So I have to reduce by 3 more days. You can do it for 2 days of A and 1 day of B, or you can do it the other way around, because you are not changing the critical paths here, and you are not having any activity which has a different per day cost. A and B both have the same per day cost. Okay, so if somebody did reduce B by 2 days and A by 1 day, or did the other way around, 2 for A and 1 for B, both of them will have the same results. Both of them will achieve the same results. So it doesn't matter in the end. Okay, in the end, whatever you are doing, you will reduce the duration to 22 days. That means minus 4 days, and you will increase the cost. Okay, so 1000 for activity C, and extra 3 days for A and B will cost you $2,000 per day. Okay, so 2 into 3 is 6,000. Okay, so total you will increase the total cost by $7,000. 1,000 coming from activity C, compression of activity C, and the remaining 6,000 coming from activity A or B. Okay, so you reduce the days by 4 and you increase the cost by $7,000. Okay, so now the question is this reduction justifiable? Can we say that reducing the duration by 4 days with a $7,000 increase, is it good or bad? Okay, can we say that we should do it? Now we just did it in terms of calculation. Okay, this is just in terms of calculation. So should we go with the calculation, or should we stick to the initial one? No, you still start with the least one. So you will always start with activity C. Okay, yes, what you are saying, I understand it. Okay, that why should we reduce C? Okay, but according to the procedure, okay, this is how it is done. You start with the least one. Okay, so in the end you may do 1 day for C, so it will be 25 days, and then 2 days out of A or B. So your cost will increase by $5,000. Okay, if you stopped at 23 days. Okay, so so the point was, should I go from 26 to 22 days? Okay, so for that they have plotted this curve. I don't think it makes much of a difference here, because in the end we are just increasing every day by $2,000 after the first day. So okay, after this, so from here to here you increase $1,000. So the curve is, you can see, slightly straight, and from here to here every day is costing you $2,000. So the curve is getting steep. So if somebody stopped here, they will have the best value. Okay, so when you stop, you have to look where the curve is changing the direction and so on and so forth. Okay, but the maximum crash you have done is for 22 days, which can cost you $26,000 instead of $17,000. Okay, and so on and so forth. So 26, so 17 plus 7, I believe the value is not correct, cannot be 26, right? 17 plus 7 is 23,000, right? Yeah, this is correct, 24. So this one should be 24. You can correct it in your notes. Okay, this one should be 24. Anyways, okay, I want to